All right, so independent events is exactly what we just looked up on your warm-up. So independent means two events. One does not affect the other. And the other one, dependent events, it does affect the other. So kind of like we talked about independent, rolling a die and flipping a coin. Just because you flip a coin and get a heads, that has literally no effect on what happens when you roll the die. So independence, no effect. Dependent, easy to remember, it's dependent on it. It does affect what happens. So now let's determine if they are independent or dependent. So number one, selecting a marble from a container and selecting an ace from a deck of cards.
Independent.
I would say independent. Two totally different things. One has nothing to do with the other. Okay. Number two, choosing a jack from a deck of cards, then choosing another jack without replacing the first card. Yeah, because when you take one of the jacks out, there's now less cards. And there's actually one less jack. So the probability that you draw another jack is going to be different than the first. Okay, number three, rolling a number less than 4 on a die and rolling a number that is even on another die. Yeah, those have nothing to do with each other. They're totally different dies.
Yeah.
Die is singular.
No.
Dice is plural.
Die is plural. Dice is singular.
Die is singular.
Cactus.
It says 4 on a die.
Yeah, die is singular.
It's like cactus and
Yeah.
cacti.
And number 4, a month is selected at random, and a day of that month is selected at random.
Dependent.
Yeah, why is that
There's
dependent?
different days in the month.
Yeah, different months have different days,
Yeah,
right?
Like if you do February, unless it's a leap year, you can draw the number 29.
Exactly. So dependent. It definitely is going to change the output or your the day that is selected there.
Oh, listen.
Okay. Now we have the probability of independent events. And what this says, it says the probability of two independent events occurring can be found by the following formula. So remember, and that's our intersection symbol. So you might see this written as the probability of A and B. And what does it tell us to do? You just multiply their two probabilities. One does not affect the other. So you just take the probability of one of them, take the probability of the other one, and then you multiply them together, and that's the probability that both of them will happen. Okay, so let's try an example. At City High School, 30% of students have part-time jobs, and 25% of students are on the honor roll. Assuming that these are independent, so it tells you that one does not affect the other. What is the probability that a student chosen at random has a part-time job and is on the honor roll? So it's asking you, what is the probability that they have, I'll say J for job, a part-time job, and they're on the honor roll, so I'll put an H there. So that tells us, so the formula says we take the probability that they have a job times the probability that they have, or that they are on the honor roll. Now be careful, we're not going to multiply their percentages. We're going to multiply, anytime we're multiplying probabilities, they're talking about the decimal, okay? So obviously, what's 30 times 25? Now, can you have 700% of something or 720% of something? No, remember, we talked about this last class. What's the highest percent?
100.
100. So obviously we're not multiplying the percents. So we're going to write them as probabilities. So the probability that they have a job is 0.3, which we know is 30%. This is what we practiced last class. Times the probability that they're on the honor roll, which was 0.25. So in your calculator, just do 0.3 times 0.25. We get 0.075. Now that's a good answer. The test might ask you to write it as a decimal. But what is that as a percent?
7.5.
Yeah, you move the decimal place 2 spots back to the right, or you can think of it as multiplying it times 100 to turn it back into a percent. So it'd be 7.5% chance. So first of all, let's start with the probability that it's a 7. So this is what we did last class. How many 7s are in the deck? 4 out of
52.
52 total cards in a deck. So if I just ask you what's the probability that I randomly select a card from a deck, it would be 4 out of 52. Okay? And then another card is chosen, and it says that the first one's replaced. So you're putting it back into the deck. Okay? So what's the probability that I get another 7? 4 out of 52 again, right? So we have to take the probability of both and multiply them times each other. So in your calculator, do 4 over 52 times 4 over 52. How do you put a fraction in your calculator? Alpha y equals 4. You could also do 4 over 52 squared, right? Because it's 4 over 52 times itself again. And you should get 1 over 169.
I got 60.
Now, if it asks you to write your answer as a fraction, that's good. Let's practice from last class. How do you turn that into a decimal on your calculator?
1 divided by 160.
Math.
Oh.
2. And you can just hit the number 2. And we'll select decimal, hit enter. And let's do 4 decimal places. So 0.0059. And then what is that as a percent?
0.59%.
Yeah, so not even 1%. So what's the probability of you drawing 2 7s in a row? Like less than 1%. It's very, very slim.
Unless
Don't
you
do it.
Okay, here's example 3. A box contains 6 red marbles and 4 purple marbles. What is the probability of drawing 1 purple marble and then 1 red marble in succession, and each time you're putting the marble back into the box? Take a second if you're watching the video, pause and give it a try on your own. Okay, here is the solution to the problem if you're watching the video at home. All right, let's first start with the probability that someone is female out of this data that's given to us. So that would be the probability that it's female is females divided by total. So the successful events divided by the total sample space. So how many total females were at this high school?
80.
Yeah, so it's over here. So it'd be 80 divided by how many total people? 164. And then we're going to multiply that by the probability, because it says and, the probability that the second student is going to the university. So where on this table are the people that are going to university?
The total 71.
71.
It would be 71. So over here, 71 divided by, yeah, the total again. So in your calculator, you do alpha y equals 80 over 164 times, you have to put a times in the middle, alpha y equals, we can put them in parentheses, 71 over 164, enter. Now it's going to give it to you as a fraction. That's a pretty ugly fraction, so let's go ahead and turn it into a decimal or percent. So math 2. That makes a little bit more sense to us. So let's round to the nearest 4 decimal places. We get 0.2, 1, 1, 2, because the 8 rounds up the 1. Or you could call that 21.12%.
I can't see that far.
So this tells us you can't just multiply the separate events probabilities. Why?
Because you
Because
won't
they
have the
have
same.
no correlation between them.
Yeah, you have to do the first thing first, right? Because the first one affects the second one. So after you do the first one, you're going to have to alter something a little bit. So for example, if you take a red marble out of a bag, your total is now reduced by 1 red marble. So you can't just do the probability of a red marble 2 times because it changes after the first experiment. So this looks kind of weird, but this is our formula. So basically what this is saying, if the probability of A happens and then B happens, see this little line? That means given. So basically, you do the probability of A, just like we've been practicing. But then, when you do the probability of B, you have to change it given what happened from A. You have to change the probability, okay? So it looks kind of confusing, but I think it'll make sense here if we just do a few examples. So let's take a look here. It says, suppose a card is chosen at random from a deck. The card is not replaced. Circle that. That's a really big piece of information. That's telling you that it's a dependent event. Because it's going to change. The probabilities change because you're not putting the card back in. And then it says, what is the probability that basically the first card will be a 7 and then the next card will be 7? Okay? So let's start off with the probability that it's a 7. So this is the first card. What's the probability that I draw 7? We've already done this once. 4 out of 52. Good. But then we have to find the and then they want to know what the probability that the second one's going to be a 7. So the way we write this, the probability that the second one is a 7, given that the first one was a 7, is what that means.
Is there a part on that? Is there
Maybe
a
3 out of 51.
No, you can't put this in your calculator. You just have to do it in your head. So think about it. How many cards are in a deck? 52. You just took one out. So how many are now in the deck?
51.
So now our total's out of 51. So the first thing to think about is the total. The first thing to think about is the total. Okay. The second thing to think about is how many 7s are there? Because there were 4,
Now there's 3.
but you just took one out. So the 7s are also reduced by 1.
Put that together.
It says, what's the probability that the first one is a 7 and the second one is a 7? So they're telling you the first one's a 7. So then they're asking you what's the probability.
0.0045%.
And now we just go back to exactly what we just did. We multiply the 2. So 4 over 52 times 3 over 51. Go ahead and put that in your calculator and come up with, let's do decimal rounded to 4 decimal places. So the correct answer is 0.0045. That's the decimal. What's the percent?
0.45.
Not 45. It's 0.45%. So it's less than 1% is what that's saying. Okay, next. A box contains 6 red marbles and 4 purple marbles. What is the probability of drawing 1 purple marble and then 1 red marble in succession without replacing? So you're going to keep the first marble out of the box. Okay, so let's start off. What is the probability that the first one is purple?
4 out of 10.
4 out of 10. Good. 4 out of 10. So we're good with that, right? The probability that it's purple. Then the probability that the next one is red, given that the first one was what? Purple. That's just the notation. If that's kind of confusing, you don't worry about it, as long as you understand the concept. So now let's think about it. How many are total in the bag now?
9.
9. Now, do I need to, is the top going to be 3?
No.
No, because they're asking, so remember, how many, there's 6 red. So 1, 2, 3, 4, 5, 6, right? And there's 4 purple. So 1, 2, 3, 4. What did I just, we just found the probability that's purple, right? So there's 1 less purple in the bag now.
So it still says. Yeah,
So it is out of 9, but what's the probability that the next one is red?
6.
It's 6. Yeah, because I didn't take any red ones out. So it'd be 6, because there's 6 red ones. So 6 didn't change. Only the total changed that time. Okay? So now, in your calculator, multiply 4/10 times 6/9. And this time, let's write it as a percent. So 4/10. This is another way you can do fractions. Put parentheses around a division sign. If you don't like doing alpha y equals. So 4/10 times 6/9. Now that's the decimal. what is the percent? And let's do four total numbers. So 26.5